Assalamualaikum and hello everyone. For our application of mechanic project, we have chosen the topic work, power and energy in roller coaster. In this presentation, we will explain how mechanical concepts are applied in real-life roller coaster system. And we are from Group JCDCS 1435E.
Before we start, let me introduce to you about the topic. For our problem, it includes chapter 5, which is work, power and energy. First is work. Work is an application of constant force moved through a distance. The formula to find work is done is force times distance, and its unit is joules. Next is power. Power is a measure of the rate at which work is done. 1 watt is equal to 1 joule of work done in 1 second. Last is energy. Energy is a measure of the capacity which the body has to do work. For energy, it has two types, which is kinetic energy and potential energy. Both of these types seem similar, but it was influenced by two different conditions. As for kinetic, it influenced by motion, while potential energy influenced by position. To find kinetic energy, the formula is mv²/2, and for potential energy is mass times with g and height. The problem statement for our group is a roller coaster of mass 5 kg is pulled to the top of hill, 40 meter height by a motor. The question asks to calculate the work done by the motor to lift the roller coaster. Second, determine the potential energy at the top of the hill. Last, find the speed of the roller coaster at the bottom of the hill.
Next, we go to the solution. For question A, calculate the work done by the motor to lift the roller coaster. The work done by the motor to lift the roller coaster is equal to gain in gravitational potential energy. We use the formula W equal to mgh. Substitute the given values, which is W equal to 500 multiplied by 9.81 multiplied by 40. So the work done by the motor is 196,200 joule. Next, for the question B, determine the potential energy at the top of the hill. The potential energy at the top of the hill is also calculated using the formula PE equal to mgh. Using the same value, the potential energy is 196,200 joule. Last question, C. Find the speed of the roller coaster at the bottom of the hill. When the roller coaster moves down, its potential energy is convert into kinetic energy. So, we equate mgh equal to 1 divided by 2 mv the power of 2. The mass cancel out, giving v equal to square root 2gh. Substitute the value, which is the value equal to square root 2 multiplied by 9.81 multiplied by 40. This given a speed of approximately 28 meters per second.
In conclusion, this presentation highlights the importance of work, energy, and power in explaining the motion of a roller coaster. Through the given problem, we calculate the work done by the motor to lift the roller coaster, which is equal to the potential energy stored at the top of the hill. When the roller coaster moves downwards, the potential energy is converted into kinetic energy, allowing us to determine its speed at the bottom of the hills. This clearly demonstrates the principle of conservation of energy, where energy is transformed from one form to another without being lost. By understanding this concept, we can see how physics is applied in real-life engineering systems, particularly in the design of roller coasters that are both thrilling and safe for passengers.